Hi, everyone. I'm going to talk to you today about client isolation. A little bit about me. I am based in Sydney. I work for Google Australia. I've been an SRE for almost 3.5 years, and the first 3 years of that I was with Geo SRE, which we can simplify for these purposes to maps. And for some context, the things that I worked with on that were mostly the stateless front ends for the third-party maps APIs, desktop mobile maps, and also some of the integration with the Google search system. So, a little bit about Google Maps. There are more pieces in Maps than you would think. And there is Maps, there is Earth, there is Street View, there is the Backend that works out directions. There are all sorts of things. And Maps has both external users, so say people who load up maps on their phone or on their laptop, and also internal users. So you might say, ask Google Assistant, how long will it take me to commute to work? That uses Maps. If you are Google Calendar and you want a picture of the place that the person has said the event is at, that contacts Maps. So there is lots. And it is all a bit complicated. I've drawn a picture before, but it took about 3 whiteboards. So what happened? I'd probably categorize it as minor to medium-sized explosions. Yes, we had lots of fun. We got overloaded, so large clients were able to send more traffic than we could handle, and that affected other users. And this was also a complicated system, so if you're the thing getting the first request, are you going to know that if you keep sending this request, something down the stack is going to get overloaded? Not really. We also had some monoliths, like everyone does. Servers that contain large numbers of different services in them. So you overload one, it was possible to affect others, and that's not great. And also, we had different static quotas around the place. Static quotas are not so fun, but sometimes necessary evils. So in our case, this was usually queries per second limit. So you ask your backend for a certain amount of capacity, and they say, OK, you have this much. But maybe you're sharing that between different things, and maybe you sometimes use it but don't always, and then suddenly you go to use it, and they've oversubscribed. There were many fun things. So we set about fixing this, and our main goal was, for client isolation, one client should not be able to negatively affect another. Seems like a good plan. And kind of the simple way is go, well, let's make this big enough such that nothing one user does can possibly affect anyone else. And in an ideal world, that would be great. Unfortunately, we have more constraints than that. I'm going to talk a little bit about load shedding today. Just a show of hands, who's familiar with the term load shedding? OK, so half-ish, maybe. So load shedding is the idea that it's taking our capacity into consideration. Capacity is not infinite, but you want to use as much of it as you can. So if you're not overloaded, you serve all of the requests you get. And if you are overloaded, then you drop some to save the others. You don't want your whole service to go down, because that would be bad. And sometimes you're picky about what you're dropping, sometimes you're not. It depends. The more processing you put into deciding how important the thing is and whether you should drop it or not, the more load you're using, so something to think about. So this adds a couple more goals. We have the nice clients should not be able to hurt each other. If we have capacity, then we want to keep serving. If we're overloaded, only drop what we need to. You could just drop everything, but that wouldn't be a very good user experience. And if you have to drop things, be specific, or think about what you want to drop. Actually, I'll get to that bit a little later. So I have for you a little bit of a simplified system. There is a client. Sometimes the client is yours. Often it is not, and it's probably better to consider when it's not, because that's the more fun case. And some of this ties a little into Ariel's talk yesterday. Good client behavior is nice, and we like that. Often, not always, I'm not sure of your specific systems, you'll have some form of DOS protection layer in here. You probably have some kind of configuration control, but not developing the whole thing, maybe. And then you have a bit of a system. So you have probably something like a stateless front end that's getting your requests, formulating what it wants to send to the backends. It might be doing some checks on, like, is this user able to do this or not, that kind of thing. And then you have your backend, which is usually a bit more expensive to run. It's doing more processing, more specialized stuff. So we came up with a few different strategies. Some of these worked, some of these didn't. Depends on your situation. We had, I will go through caching, quotas, prioritization and load shedding, microservices, and separate stacks. So caching, and yes, caching, I say, because Australian. If you can serve a request from cache, this is often cheaper than running it through the rest of your processing. I say usually. I have actually seen a case where a cache hit was more expensive than issuing the request, and that was a bit bizarre. It's often easy to add in, which is kind of nice. It can go well. Sometimes you can put it transparently in, sometimes you make a call out. It depends. But it doesn't always work, as is true of many easy things. So if you're trying to do a write, can't really cache that. Sorry. If you have like very personal data like PII, you might not want to cache that for security reasons. You might also have maybe the request includes like a timestamp with milliseconds. Unfortunately, caches are not very good for those. You might have strict consistency requirements. And it might also be that your system is involved with billing. Maybe you have to pay for this request. If you're caching the request, you want to make sure that you still send the data through to the billing system that says, I served this, please charge the person for this. And this is quite good for if you have the capacity to serve it, then do so. You might want to put this pretty early in your stack so that you get the best you can from saving processing further down. Quotas. Quotas are interesting in that people have different ideas of what quotas are for. If you're a client and you say, I want 100 QPS for this, then you're going to expect that they will give you that 100 QPS. That is your guarantee, your bucket. You can use it or not use it as you like. Unfortunately, quite often, the service owners will think of it more as a limit. This is the most damage or load you can send to me, but you're probably not going to use all of it. And unfortunately, this can lead to oversubscription. And we discovered in our stack, as a fun fact, that one piece was oversubscribed by approximately 7x. And we were just really lucky that nobody tried to use all of their quota. And because they're static numbers, they're actually reasonably easy to implement. It makes them a bit brittle, but they do have their place. So you can bucket off users at a certain spot and go, well, this is the most they can do. But unfortunately, it affects many of your other problems. So yes, use sparingly. Prioritization and load shedding. This was one of the ones that we found actually quite useful. Not all of your traffic is created equal. You don't actually care the same about every single request that comes through quite often. Maybe you have a service that only does one thing, and maybe this will not be useful to you. But say you have a user, and they have opened Google Maps, and they have searched for a place, and they kind of care about the result of where is that place. And they would like that request, and you probably don't want to drop it. You might have some kind of quality thing. Maybe they're searching for restaurants, and you want to show the top 20, but maybe if you only show 15, they might be okay with that. You might have, say, a background process. Every 3 hours, it's going to work out roughly where you are and what the weather is. You probably don't care so much if it happens exactly at that time, but you'd like it to get done at some point. And then you might have batch jobs. Someone maybe internally has a map produced, and they want to go over all of your streets and, I don't know, count them, something. They can probably wait till later if your service is overloaded. So if you can categorize your traffic, you can work out which you care more about, which the SLAs are more important, and serve those and drop the others. And this can be nice. It helps improve your utilization. You probably don't want to be, well, it depends. You don't want to be at the point where you have to be dropping things that people care about constantly, but it's a nice safety hatch. And it's good degradation in that if there is an outage, the people who care the most will hopefully be the least likely to notice. And a nice one that we discovered is when you start saying, well, what is more important? Everyone goes, mine. Mine is important. Yes. But if everyone is the highest priority, then you lose all of the benefits and nobody is the highest priority. So be very careful of this. And also be careful of priority inversion. We had an interesting problem where we would do some request gating. So if the same request was being issued, we would wait for that to come back. But sometimes it would be a higher priority request waiting for a lower priority request. And we had to do some changes around that to make sure that was not problematic. There were also microservices. This was probably not our largest problem, but it was still kind of important in that we didn't want to limit some of the damage, and it gives you other benefits. It makes your infrastructure nicer. And show of hands, how many of you have heard the phrase, well, we just put it there because we didn't want to write another server and have to go through the process of handing that off to SREs? Yeah. We were a little bit of, we fell victim to that in some cases. And that helps not just with one client not affecting another. If you have one client that's doing something strange with checking the elevation of a point, you really don't want that to be affecting some completely different client who's searching for directions. Why are they connected? They're not. Separate stacks. This is pretty good at getting isolation between clients. Unfortunately, it has some of the bigger resource requirements and also toil requirements. If you have to look after a lot of different stacks, it's going to get painful. Like if you have 3, might be okay with that, but we couldn't make a separate stack for every Google Maps user, unfortunately. So, yeah. But it would work really well if it had been applicable to us. This was a fun one that we came across. Not necessarily specifically related to the previous point, but this user is very, very important. Just exempt them from client isolation. But if you think about it, exempting someone from client isolation doesn't really make sense. What they're actually trying to say is, I don't want any of their queries to be dropped, which means they won't be affected by any other clients, but probably the other clients will be affected by them. So essentially, you destroy some of the client isolation you have. Short of giving them a separate stack, which, if they're a big enough user, then maybe. But otherwise, you don't really have client isolation. And a nice little maxim for that is if they're big enough to be asking you to exempt them, they're probably big enough to cause damage. So beware. If we go back to the system a little bit, I will go through what things we looked at for different spots and why. So ignoring the client for now, because we will assume, as is often true, that they are not a problem. DOS protection. DOS protection is rather nice in that it protects everything behind it. That's what it's for, which is great. And it's usually pretty cheap about being able to do this. But it doesn't really understand what's going on behind it. So you can end up with collateral damage. If it's going, oh, there's a lot of requests coming in, I'm going to limit those a bit. Possibly somewhere else in your stack was going to go, oh, actually, this user is over their quota, so I'm going to limit them. And unfortunately, you didn't know that, and you've blocked someone else's traffic further up. And it also, wait, never mind, I said that. Sorry. To your front end. It knows a bit about which backends are needed for each request. So you might have some requests that don't require the backend that is melting, and those are perfectly fine to go through. And your front end can tell this. And it's a simple place to reject things like with billing, if someone is paying for the request, before you get to the backends where all the expensive processing is happening. But it doesn't quite know how overloaded the backend is. The backend knows this and the front end does not. So you could have either way. You could overload them or you could block prematurely. And you come to your backend. Your backend is good at optimizing for backends. This is unsurprising. But by the time you get here, you've already used a bit of compute. So if you're dropping something, you've already wasted a bit, which is unfortunate. It doesn't protect anything higher in your stack. And we had an interesting case around fan-out. Your front end might be sending 100 requests to your back end, and if one of them fails, the request fails. That turns out badly. So yeah, there are things you can do which are beyond the scope of this. And Okay. It tried to go to sleep there. Sorry, I will just try the old plug it out and in again. Oh. Right, so a little bit of a summary. So what did we do? At the DOS level, we put in some quotas, sort of large enough that the user probably shouldn't hit them, but enough that if something went horribly wrong, we would not get too much damage. The front-end level was probably where we did a bit more. We had some quotas. This is the point where you can probably best judge what priority your request is. So we did that there and added in tags that the backend could see. We did some caching, and we did some work around microservices. For the backend, we did some caching where possible. This is not always. And we did some load shedding where possible. Some of the backends we did not own. So we added our own quotas in front of them. And microservices, although backends tend to be more specialized, so you're less likely to have the monolith problem, I find, at least for us with backends. Like they usually, this is a rather specific architecture and therefore it sits by itself. Some caveats. You might not own all of the stack. We didn't. This can make it a little fun. And you can't control what they will do when they are overloaded. So if you can prevent it, that is good. And if not, handle it the best you can. Not all strategies work everywhere. We tried some things that did not work. We tried some things that did work. Things that did work were good. And it's probably unlikely that you will have the silver bullet of the front end. This is where I will solve all of my problems. It's probably going to be a combination of things everywhere. Some benefits that I might have mentioned along the way. Microservices are nicer for your architecture overall, makes them a bit easier to reason about, etc. Load shedding can improve your resource efficiency, and I like efficiency. And my parting request, understand your queries, that they are probably different, and work out how to prioritize them. This is good for your clients because the ones who care more will be less likely to notice when you're overloaded. Your resource manager will be happy because you'll have better utilization. You may also be your own resource manager, bonus points for you. And it makes you happy because you'll be less worried about overload because you know it will behave sanely. So, questions? And that is my email address.